The following video presentation describes the installation of a Sessil trickling filter located at Cott Beverages USA Incorporated in Wilson, North Carolina. This video shows how NSW works with industries, engineers, and contractors in designing and furnishing components for Sessil trickling filters. First, a quick overview on Sessil trickling filter media. Sessil is a completely vertical strip-type trickling filter media without any packing interfaces. These characteristics make Sessil ideal for treating high-strength industrial and municipal wastewater with high BOD and/or high TSS concentrations. As with all trickling filter medium, bacteria adhere to the surface area of the media. These bacteria reduce the BOD concentration by consuming compounds responsible for making up the BOD and produce more biomass. Some of the biomass constantly falls off the media due to the flushing energy from the applied wastewater. Without packing interfaces, the sloughed biomass and normal suspended solids in the wastewater cannot accumulate on the Sessil media. Influent suspended solids and sloughed biomass fall directly to the trickling filter floor and are washed out to the recycle pump station. In 1997, Cott Beverages started up a beverage bottling plant in Wilson, North Carolina. Initially, the local POTW surcharged Cott for treating the wastewater from the bottling operation. However, as the local POTW became organically overloaded, city officials required Cott to construct a pre-treatment facility to reduce the BOD in the wastewater. In late 1997, Cott engaged the consulting firm of Green Engineering to perform a feasibility study to determine what treatment alternatives would be most cost-effective. Green Engineering determined that a two-stage system featuring a Sessil trickling filter for roughing would be the most cost-effective alternative. Overall, the system incorporates a flow equalization basin with pH control and nutrient addition, a Sessil trickling filter followed by a package extended aeration plant with an aerobic digester. The Sessil trickling filter was designed to remove 70% of the soluble BOD, with the extended aeration plant responsible for polishing the wastewater to discharge limits. As a result of a tight project schedule, the project had to be fast-tracked. Because of NSW's experience in designing and supplying Sessil trickling filter components, including the rotary distributor, galvanized steel support structure, fiberglass paneling, and so on, NSW furnished the contractor, T.A. Loving of Goldsboro, North Carolina, and Green Engineering with foundation loading information and the base slab layout. NSW recommended a 12-sided Sessil trickling filter with a nominal diameter of 30 feet and bed depth of 20 feet, with an overall height of 28 feet. For construction in the United States, the most cost-effective way to construct a Sessil trickling filter is to incorporate a galvanized steel support structure with fiberglass panels attached to the exterior structural columns and horizontal girts. The fiberglass panels keep the wind out and the wastewater contained, and they provide an aesthetically pleasing look at a reasonably low cost. Construction of the Sessil trickling filter began in November 1998. The overall process of erecting the trickling filter was straightforward. Once minor grading was completed and underground piping was installed, the concrete base and ring wall was poured. The base was sloped at a minimum of 2% towards a central drainage trough. This trough was also sloped at 2% towards the pump station located next to the trickling filter. The ring wall was poured with an outer lip to contain wastewater washing down the inside of the fiberglass panels. After allowing the concrete base to cure, erection of the galvanized steel support structure began. The structure was designed to support a media operating weight of 20 pounds per cubic foot. The support structure consists of I-beams, angle, flat stock, and cross bracing.